recognizing linear and nonlinear functions. So this whole chapter we've been talking about functions. A function is a relation where each input has only one output. So we're still talking about situations where a relation has each input has only one output. We've been focused really on linear functions. And we've been talking about that the linear functions have a basic pattern to their equation, y equals mx plus b. So linear functions have a straight line, they have a slope, and they have a y-intercept. So a linear function has a constant rate of change, which we call our slope. So we can look at an equation and see that it looks like y equals mx plus b, or y equals mx if the b is 0. A nonlinear function does not have a constant rate of change, so it doesn't increase or decrease at a constant rate, and its graph is not a straight line. So we're going to start to look at some graphs, some situations, relations that do not represent linear functions, and we're going to try to determine which ones are linear and which ones are not linear. So we're going to start by looking at some tables and deciding if they're linear or not linear. So here is my table, and again, from a table I want to look for a constant rate of change. So I'm going to see what the input does, and in this particular table, my input increases by 7, and I'm going to see what my output does, and my output increases by 5 each time. Now, we want to look for a slope here. If our input's not in a nice particular pattern, I want to pay attention to that. But I want to look for my slope, and remember my slope is my rise over my run. My slope is how the y changes over how the x changes. So the y is changing by 5 every time the x changes by 7. So my slope is 5 over 7, which means this is linear because it has a constant rate of change. So if I were to graph this, I would get a nice straight line on a coordinate plane. Second one, again, we're going to look for constant rate of change. So my x values have a lovely pattern to them, which is great. So these increase by 2. And then my y values decrease by 4. So again, if I think about slope here, my rate of change, my slope is the change in y over the change in x, so 4 over 2. So I have a slope of 2 here. So this is linear because it has a constant rate of change, which happens to be 2. So I've got two tables here that both represent linear functions. Let's take a look at some graphs and see which ones are linear. What do those relations look like when I graph them on a coordinate plane? So here I have a graph. And again, is it linear or is it not linear? Does the graph represent a linear or nonlinear function? And explain. So when I look at this one, remember my linear function, it has a constant rate of change, a constant slope, and it's going to be a straight line. This is not a straight line. It's a lovely function, so it's still a function. Each input has only one output. However, it's not linear. So this is nonlinear because it's not a straight line. Explanation's pretty simple here. Let's look at number 4. So again, is it linear or nonlinear? Now this is also a function because each input has only one output. However, it's made up of 2 separate sections. Now, each section is linear, but the entire function, if we look at it as a whole thing, is not linear because I can't just graph the whole thing with one straight line. So this is nonlinear because again, it is not one straight line. And our last one, which looks very familiar to you here, here we have a very nice straight line as my function. Again, each input has only one output, but you'll notice that my entire function is one straight line. So yes, this is linear. It is a straight line. So again, linear versus nonlinear. Linear has a constant rate of change, a slope, and on a graph, it makes a perfectly straight line. Whereas nonlinear does not have a constant rate of change. So you'll notice here we don't have a constant rate of change as we go through the entire function. Here, same thing, we don't have a constant rate of change. Part of this has a positive slope and part of this has a negative slope. So these are non-linear functions because they do not make one straight line on my coordinate plane and they do not have a constant rate of change.